Hello viewers, welcome to my channel. Second Math Hub, the solution to your math problems. Still on trig, angle of elevation. Question number 7. 2 points A and C are on the same level ground as the foot of the pool. So this statement here should guide us draw something on the board. So now, this pool here will definitely be erected on a level ground. So we have our ground here, and this is our vertical pole. Now we were told that the foot of the pole should be labeled as B. So here is B. And then we know that the pole would meet the ground at an angle of 90 degrees. So we should note this. Now, again, we were told that these 2 points, A and C, are on the same level ground as the foot of the pole. So where should we place A and C? Should we place them on this side, or we should place them on the other side? Or again, should we place them on the opposite side of the foot of the pole? So per the first statement, much information was not given concerning the specific positions of these 2 points. So let's keep on reading. The angles of elevation of the top of the pole D. So it means that the top of the pole should be labeled as D. From these 2 points, point A and point C, measures 30 degrees and 48 degrees respectively. It means that when you measure the angle of elevation of the top of the pole from the point A, that should give us 30 degrees. And when we measure the angle of elevation of the top of the pole from the point C, that should give us 48 degrees. But since we don't know the exact position, let's keep on reading. Now, if the distance between A and C is 50 meters, again, they've given us the distance between these 2 points as 50 meters. So with this, we have to find BD. We have to find BD. So we say that BD is the height of the vertical pole. So I've represented the height of the vertical pole as H. So to find the height of the pole, if A and C are on the opposite side, so they're giving us the exact position that those 2 points are located on the opposite sides of the vertical pole. So meaning that if point A is located at this point, then the opposite side should be here. So here is C. So with this, we can measure the angle of elevation. So as we saw from the question, the angle of elevation of the top of the pole from the point A measures 30 degrees. Again, when we measure the angle of elevation of the top of the pole from point C, that should give us 48 degrees. Don't forget that we were given the distance between A and C. So the distance between A and C was given as 50 meters. So the distance from A to C was given as 50 meters. So with this, we have to calculate the height of the pole. Now, when you take a closer look at the diagram, you can see that we have 2 right angle triangles. This is the first right angle triangle and the second right angle triangle. So let's label them. So the first right angle triangle, I'm labeling it as triangle ABD. And the second right angle triangle, I'm labeling it as triangle BCD. So let's take notes. Now, I am representing the distance from A to B as X the distance from B to C as y. This will make the calculation very easier for us. So that is what I've done. So now let's identify the sides of the right angle triangle. Starting with the first right angle triangle, triangle ABD, triangle ABD. So this side here becomes the hypotenuse because it is the longest side. And again, it is the side facing the 90 degrees angle. We know that angle on the straight line sum up to 180 degrees. So if this side here is 90 degrees, then this side here must also, or the angle here must also measure 90 degrees. So that makes line AD the hypotenuse. Which side is the height of the pole? So the height of the pole becomes the opposite. Why? Because this side here faces the acute angle. We said that the opposite is the side facing the acute angle. So the height here is facing the 30 degrees. So that makes it the opposite. And then obviously the remaining side becomes the adjacent. Let's also label the sides of the second right angle triangle. I'm talking about triangle BCD. BCD. So this side here becomes the hypotenuse because it is the longest side. And the height of the pole also represents the opposite because the height of the pole faces the acute angle here, which is 48 degrees. So this height here is still the opposite. And then obviously the remaining side becomes the adjacent. So now how do we calculate the height of the pole? Using the first right angle triangle. So from the first right angle triangle, we labeled it as triangle ABD. So now from triangle ABD, we know the height as H, which also represents the opposite. So we know the opposite, and then we also know the length of the adjacent as X. So we have adjacent. So from SOHCAHTOA, which of them has opposite adjacent? So that is TOA. So it means that to calculate the height using the first right angle triangle, we have to go by TOA. And what does TOA say? TOA says that the tan of the acute angle, 30, should be equal to the length of the opposite. So this side is the opposite, represented as H, divided by the length of the adjacent, which is X. So tan 30 is the same as tan 30 1. We can cross multiply. So what is X times tan 30? That should give us X tan 30, and then 1 times H. Now let's make X the subject. Why are we making X the subject? Now we were told that the distance from A to C measures 50 meters. And we could also see that the distance from A to C has been divided into two. One part measuring X and one part measuring Y. So it means that when we sum up the distance X and the distance Y, that should give us the 50 meters. So that's why we are making X the subject. So how do we do that? We have to divide both sides by tan 30, tan 30. So the tan 30 will cancel out, leaving X is equal to H on tan 30. Now let's also calculate the height of the second right angle triangle. The height of the second right angle triangle. So to calculate the height of the second right angle triangle, we know our opposite as H. We know our adjacent as Y. So we still go by opposite adjacent. And then from SOHCAHTOA, TOA has opposite adjacent. So it means that to calculate the height using the second right angle triangle, we have to go by TOA. And what does TOA says? So TOA says that the tan of the acute angle here, 48, must be equal to the length of the opposite. So the length of the opposite from this triangle is h divided by the length of the adjacent, which is y. So tan 48 is the same as tan 48 on 1. We can cross multiply. Y times tan 48. Y tan 48 is equal to, and then 1 times h. Again, let's make y the subject. So how do we do that? We divide both sides by tan 48 here by tan 48. So tan 48 will cancel out, leaving y is equal to h on tan 48. Now, how does the distance x and the distance y relate? Now you could see that when you sum up the distance x and the distance y, the distance x and the distance y, that should be equal to 50 meters. So you should be able to set up an equation. So the distance x plus the distance y must be equal to 50 meters. So now let's substitute the expression for x and expression of y into the equation. So what did we get for x? So x, we had h is equal to tan 30 plus what do we get for y? H on tan 48. And everything should be equal to 50. Now we have our equation, everything in terms of h. So at this point, we want to solve for h. So how do we solve for h? How do we solve for h? So you see that we have a fraction here. So to eliminate the fraction, you have to multiply each term by the LCM. And what is the LCM? So the LCM is tan 30 tan 48. So that is the LCM. The LCM is tan 30 multiplying tan 48. So now let's multiply each term here by the LCM. So starting with the first term, you're multiplying by the LCM. The LCM is tan 30 tan 48. Multiplying, so let me do it this way. Multiplying the first term, which is h on tan 30 plus the second term times the LCM. So tan 30 tan 48 multiplying the second term, h on tan 48. And this should be equal to the third term here multiplying the LCM. So tan 30 tan 48 multiplying 50. So let's simplify. So we could see that tan 30 will cancel out the first term. The second term, tan 48 will cancel out. So that should give us tan 48 times h tan 48, that is for the first term, plus we have tan 30 times h tan 30, and everything should be equal to 50 times tan 30 tan 48, that is 50 tan 30 tan 48. So how do we solve for h? We see that we have some h is a like 10 here, so let's factorize h out. So we'll be left with tan 48 plus tan 30. Then everything should be equal to 50 tan 30 tan 48. We are looking for h, so we can divide both sides by tan 48 plus tan 30. And here we also divide by tan 48 plus tan 30. You're almost done. Again, these two will cancel out, leaving the height, that is h is equal to 50 tan 30 tan 48, all divided by tan 48 plus tan 30. The rest is calculator work. So using our calculator, let's enter this fraction into the calculator's memory. So for the numerator, we have 50 tan 30 multiplying tan 48 divided by the denominator tan 48 plus tan 30, and that is giving me h is equal to 18.99 meters to 2 decimal places. And this brings us to the end of this episode. I hope you enjoyed the lesson. See you. Bye bye.